Hey guys, what's up? Today we're going to look at the dot product and we're going to see what the dot product actually is. There are two definitions people use for the dot product. The first one, the analytic or the algebraic definition, would just be the multiplication of the corresponding components and then adding those all together. That would be given in summation notation here. AI times BI. Add all those from 1 to n. So A1, B1. Plus A2, B2 plus A3, B3. Just multiply the corresponding components and then add all the terms together. The geometric definition, which would be a theorem if you start out with this definition, but they're equivalent. The geometric definition would be A dot B is given by the magnitude of A times the magnitude of B times the cosine of the angle between them. So this just gives us a number. So this dot product is often just called the scalar product. It just produces a number given two vectors of the same size. So let's look at an example, a quick example, just using the algebraic definition. If we want to take the dot product of these two vectors, we would take this vector, 1, 2, 3, dot product was 0, negative 3, negative 4, and I multiply the first two components together, 1 times 0, 2 times negative 3, plus 3 times negative 4. So that would give me negative 6, negative 12 is negative 18. So that's a quick algebraic definition application. Now, what does it tell us? It doesn't tell us anything. It just gives us a number. What does it tell us? Well, from the geometric interpretation, we can see that it has something to do with the angle between the two vectors. So theta here is the angle between the two vectors. So, for example, if theta, this angle here, is less than pi over 2 or less than 90 degrees, it's an acute angle, then the cosine of that is positive. So the dot product would be positive. Magnitudes are positive. And then cosine for angles that are less than pi over 2 and greater than 0 would be positive. So that would give us a positive dot product. So whenever the dot product is positive, we can say that the vectors more or less kind of point in somewhat the same direction. However, if they're perpendicular, then the angle between them is pi over 2. Well, the cosine of pi over 2 is 0, so that tells us our dot product would be 0. When our vectors are perpendicular, the dot product is 0. Right, and lastly, whenever we have the angle being greater than 90 degrees or pi over 2, then we would have the dot product being negative because cosine is negative for angles greater than pi over 2, less than pi, or between 90 and 180. Now, if this side here continued on to extend this way, so if this were our vector, then we would take this to be the angle between the two vectors. It's always the angle between 0 and 180, or 0 and pi. So we wouldn't say that this angle is the angle between the vectors. We would say that it's the angle less than 180. All right, so kind of in summary, the dot product tells us whether or not the two vectors are pointing in the same general direction or opposite directions, or if they're perpendicular. We can know that they're perpendicular if their dot product is 0. And that's pretty much what we will need from the dot product.